And this pizza reminds me of the garden, which was in the first video. And inside of the pizza, the sauce is masala sauce. So it has spices in it. And those spices also remind me of that video, the anointing part. So this video will explain the math more to help you follow the rubric. This video is not meant to replace the other video. It is just to continue and help you know what we're doing. The pizza is round, and when I bought it, they called it 10 inches. I'm in the United States, and we still use inches more than centimeters most of the time. I could think of these units as being each 2 inches. So remember from the story, the stone is supposed to be large or lithon, and it was rolling. Remember, this is a circle roughly. Of course, it's not perfect, just like the pizza's not perfectly round. And the diameter is 10 inches. The radius is half the length of the diameter, just 5 inches. The area of the circle is, in the US, most people call it pi r squared, even though this letter is better to be pronounced as P, but we already have P for something else. Let's say this is a model of the stone. Well, how does that make any sense? So when I was looking online, there's this idea that in front of tombs for rich people, which this was supposedly donated by a rich person, there is a dip like this, something like that. So it's not so hard to push it in front of the tomb, but it's harder to push it away. So remember, a circle has a center, and then we could get into more information. The center is at h comma k. One formula is x minus h squared plus y minus k squared equals r squared. If I wanted to label my points, I could. So this center is at h comma k. This position here is h plus 5 comma k. This one is h comma k plus 5. And this one is h minus 5 comma k. And this one is h comma k minus 5. So we have these 4 points. So this is one potential model. Don't use mine because this is way too small. In the story, remember, it's large. And we don't want to use the same model as anybody else. So the area of it's pi r squared, which is pi times 5 inches and then squared. And if you live in a place that uses centimeters more, these two little guys mean inches. The two over there is an exponent. Pi is a constant. 5 times himself is 25. Inches times himself is square inches. 25 times pi is greater than 75 square inches. Again, this is too small for the story. If I wanted to make my stone that small, I would have to put a star and explain it, but that's dangerous because if the explanation is not that great, the person grading, which is me, I might just think you're trying to be cheesy. So I can't think of a good reason to not have a curve, but you might come up with a good reason. Okay. Now, not all curves are circles. What if we had a curve down here And then we had a rectangle cross section right there. Then what? Remember in the rubric, we have to get the area of the stone where it touches the tomb. So now we have a semicircular area. We could call it region A and a rectangular region B. So region A is half the area of the circle. Now we'll get an approximation. Pi times 25 is around 78.5 square inches. Now, kind of like the pizza that's not perfectly round, this wheel or stone probably wasn't perfectly round. And when I looked into it, the archaeologists think that it was made out of a dense limestone. And limestone is supposedly old coral and other things, but it's dense. So that means that it's a little bit, at least a little bit jagged. And we're going to be approximating. So the area of region A is half of 25 pi. The area of region B is 2, 4, 6. So across this is 10 inches. So the area of a rectangle is length times width, which is going to be 10 inches. That's the diameter of the circle, times that far. And from here to there is 5. So 50 square inches. When an inch gets multiplied with an inch, it's a square inch. So A plus B is approximately 50 plus half of 78.5, which is going to be 89.3. So this model with the rectangle has more area than the model that was just a circle. And the difference is 89.3 minus 78.5. That is talking about the stone. That is probably the harder part. And remember in the rubric, you have to have a curve in the stone unless you want to be dangerous and give me a star. So this video is not meant to replace the other video. You should watch both. But I want to remind you that the rubric page 1 says the area of the face of the stone must be at least approximately correct for your model. And the shape of the stone should have at least one curve on it unless you explain why, not with an asterisk or star. And then it also says the area of the tomb opening must be at least approximately correct for your model. When I was researching this, the idea was that people would typically stoop to get into the tomb. Let's say this stone is way too small right here, but let's make a more realistic opening. We could change the scale. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 units. And let's make them 12. So you don't have to use imperial units. You can use metric if you want. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's probably too tall. Let's change it to 4 feet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12x equals 4 feet. And x equals 4 over 12 feet. And that's 1/3 of a foot. but we can change it to inches by saying there's 12 inches in 1 foot. And then we can cancel these two. And 12 over 3 is 4 inches. So each of these little guys is 4 inches. We've got 4 feet wide. And then each of these goes up by 4. So 10 of them. So this is 48 inches, which is 4 feet. If I go up 10, let's say I went there more wide than tall. Maybe that would be easier to bring the body in. So 10 fours, each of them is 4 inches. So this is 40 inches. And if I want to change that to feet, 12 inches and 1 foot, the inches cancel. Boom, boom. And you get 40 over 12 feet, which is 20 over 6 feet, which is 10 over 3 feet, which is 3 feet, 4 inches. Every 3 of these makes a foot. That's 1 foot, 2 foot, 3 foot, and a third. Okay, so what's the area of the opening? So like we said before, the area of a rectangle is length times width. I'm going to use inches. So 48 inches times 40 inches. Are they going to be square inches? Yeah, because inch times inch is square inch. And then 48 times 40 is 1,920 square inches. So in the US, we put a comma right here, but other countries don't necessarily do that. I think they might put it something else. So this is the area of this example. Don't use my example. And now for the difference. So in the rubric, it says the overlap should be calculated like this correctly. Area of the stone face minus area of the tomb opening. And a positive difference means more overlap than opening. A negative difference means more opening than overlap. So the difference is the area of the stone. So let's use this complicated one, 89.3 square inches minus the area of the opening. So this one does not make sense in terms of the story because there's just so much openness there, right? So in the story, the stone should cover more than this tiny little piece that is really smaller than this. Okay, so what does that have to do with pizza? So this pizza is kind of like the stone, and the naan, maybe it's a little bit like the opening behind it. So we could put the naan behind the pizza like this. And now the stone, it doesn't fully cover the opening. There's a little bit left. So if we get the area of the stone and subtract the area of the tomb, we're going to have little minus big, which is negative. And the negative means that there's more open than overlap. A negative difference means there's more opening than overlap. So that pretty much explains everything. And when you're done, remember to scan your answer and upload it. Now I'm going to stick around a little bit longer for people who still need more help. Okay. So I have two nieces that are not old enough to participate in this challenge. But if one of them was at least 18, then she could participate. So let me just pretend like I'm helping her. So we'll say her name is Annie. This is the Annie example. All right. So Annie, hopefully you've read the rubric and watched the other video. I know the rubric is 2 pages long, but it's a big deal because people are going to win $100. It's possible to win $200 or even $300, depending on if yours stands out the most. In order to stand out the most, you have to make it special in unexpected kind of ways. If you can't think of anything to do to make it special, at least make it pretty, because art helps. So you remember the story that because you watched the other video, and there's a tomb and there's like a door to the tomb. Then there's this thing called a stone that covers it, that used to cover it. You don't have to have dots on your paper, but you can. And you don't even have to have rulers, but remember, a couple of the best ones are going to be given $100 on top of the 20 randomly selected ones. So some people think of a tomb maybe looking like this. We could even make this like a triangle, I guess. So this is a model or a sketch, right? So maybe the doors, it's got a triangle kind of thing up here and a rectangle down here. This is a polygon, and we're going to have to calculate the area of it. But then there's a stone that covers it, at least somewhat. And if I'm not trying to make it too hard, I guess I could just make it a circle. So here's a circle. 1, 2, 3, 4, 5, 6, 7, 8. The diameter is 8 of these units. And I don't have a compass, but I'll just try to sketch it kind of like this. All right, maybe that'll be it. But in reality, we could shift this down because they had these dips supposedly in front of the tombs, but that would be maybe a little too far. So we could shift it like that much and translate it downward. Okay. So this is my model, and we have regions A, B, and C. And the area of A is pi r squared, which is pi times half the diameter. So the diameter is 8 somethings, and my niece lives in the US, so she knows more about feet. So let's say the diameter is 8 feet. So the radius is 4 feet. So it's 16 pi, which is approximately 50.3 square feet. The area of B, it's so easy. So 1, 2, 3, 4, 5 feet by 1, 2, 3, 4, 5 feet. It's just length times width, but it's also length squared because it's a square. The length and the width are the same. So 5 feet times 5 feet is 25 square feet. So without including the triangle on the top, the stone is way bigger than the opening, right? The stone is about twice the size of the opening. But we have this triangle part, and the area of the triangle is 1/2 base times height. And the base is 1, 2, 3, 4, 5. And the perpendicular height is 1, 2, and a half. Because I was going to make it a semicircle a while ago, but I changed it to a triangle. So it's 2.5 tall. So the area of the triangular portion is 2.5 times 2.5, 6.25. So that's 6.25 square feet. This is the area of the face of the stone face. And then the area of B plus the area of C is the area of the opening, which is 31.25 square feet. And then we're going to do stone minus door. So the difference is 50.3 square feet minus 31.25 square feet. That's 19.05 square feet. And let's check that. $19.05 square feet. So the difference is positive. So there's more overlap than opening. So even if we translate it downward like this, there's still going to be more overlap than opening. Okay. And I would say, Annie, good job. And what else do we need to do? So we're not going to win the beauty prize, probably, right? So I can go around and explain myself a little more. put a rectangle around this answer. I can label the steps. That's step 1, 2, 3. And then I need to scan this and upload it into the Google form. And that's it, except that I could be randomly selected, but I probably wouldn't win the contest for the one that pops out the most because there's not much popping out. So hopefully everybody understands it. You can email me if you don't understand something. Also, you can go to Patrick JMT on YouTube, and this guy makes math tutorials. That stands for just math tutorials, I think. And he can help you. His videos can help you with circles, squares, and so on. Or you can also email me at bam@bibleactionmath.com. So everybody have a great day.